Hi there. While acoustic waves can propagate much further underwater as compared to electromagnetic waves, they come with their own set of challenges. Firstly, sound travels approximately 200,000 times slower than electromagnetic waves in water. In air, it travels another 5 times slower. This is the reason why you hear the thunder a few seconds after you see a lightning bolt. This slow propagation speed results in a latency in communication, making acoustic modems unsuitable for applications requiring real-time responses over long distances such as remote controlling of an underwater drone. The acoustic bandwidth available is also limited. Most underwater acoustic modems use frequency bands in the few kilohertz range, offering very limited bandwidth compared to their terrestrial counterparts. The data rates of these devices typically range from few bits per second to a few tens of kilobits per second, which is tiny as compared to hundreds of megabits per second of speed that we are used to in the terrestrial world. Relative motion between the transmitter and receiver causes Doppler, complicating communications even further. Shallow water environments, like those found in ports and coastal areas where ADCPs are often deployed, tend to be reverberant, leading to multipath interference, further limiting communication performance. Underwater environments are extremely dynamic and vary dramatically across different geographies and times. Biological noises and bubbles due to wind, surf, or ship propellers also significantly affect underwater communication. Rapidly changing conditions in the ocean make it difficult for a traditional communication system to maintain consistent performance. The key to consistent performance is the development of techniques optimized for underwater environments to address low bandwidth, high noise, dynamic channel conditions, and significant Doppler. Adaptive techniques can be used to cope with dynamic environment, providing optimum communication performance even as the environment changes. Additionally, instead of simply transmitting all the sensor data, acoustic smart modems can analyze and process data locally and only transmit relevant snippets and summaries to conserve both bandwidth and energy. Incorporating machine learning techniques for content-aware data processing, smart modems can intelligently prioritize and manage the data they handle, utilizing the limited available bandwidth and battery power. Finally, making the system easy for users is also very important. Providing an intuitive user experience through a well-designed multi-platform interface ensures that users can quickly and easily access the information they need without having to spend hours struggling with complicated systems at sea. In summary, the main challenges of using acoustic modems include significant propagation delays, limited bandwidth, Doppler due to motion, multipath interference, and the dynamic nature of underwater environments. By combining impactful features such as advanced communication algorithms, data processing at the edge, and an intuitive user interface, many of these challenges associated with underwater acoustic modems can be effectively addressed. This results in reliable and efficient underwater communication systems that are a pleasure to work with. Thank you.